Hi guys, welcome back. I'm sorry about the clicking sound with the pen. I know that's super annoying. I went to the computer lab, but there was no one there to get some help, so I will try to get that gone by the next time you see a video. Okay, so multiplicity. Multiplicity just means the number of times a zero occurs. Remembering that the word zero means x-intercept. Okay, so there are two different types of multiplicity. There's even multiplicity and odd. And I think some people confuse multiplicity with end behavior. So remember, end behavior is really the end. Where are the arrows? Is it an even degree or an odd degree? Multiplicity doesn't really have to do with degree. Multiplicity, for example, if I have these two functions, notice that the exponents are both even. And so when I'm graphing this, x is equal to -1 in both of these. And so what ends up happening is when the exponent is even, instead of going straight through the x-axis, I like to call it either a bounce or a turning point. So I'm going to come down. I know that this is a parabola, right? So I know that my end behavior looks like this. But when I come down, instead of going straight through the x-axis, it's almost like a lava line. Like I hit, and then I go quickly back, bounce back up to the top. Okay? So instead of going through that x-axis, I just went straight up. This one works the same exact way. There's going to be a turning point. I'm going to go down. Instead of going through the x-axis, I bounce, and I quickly come back up. Okay? And odd multiplicity goes straight through the x-axis. So for example, here my exponent is 5. That's why it's odd. So x is equal to 1. I know that my end behavior looks like this, right? Because it's an odd degree. And so I'm going to start, and instead of bouncing and coming this way, I'm going straight through the x-axis. So an odd degree just goes straight through the x-axis. An even degree bounces and comes back up to where it started from, okay? So let's try to practice that down here. So the first thing I'm going to do is I'm going to recognize that this is a third degree polynomial because I see 2 x's here and 1 x here. The next thing I'm going to do is I'm going to break up the x-intercepts. So x is equal to -3. Now because of this 2, we call this a multiplicity of 2. All that means is that that x-intercept is occurring twice. Okay, it's happening twice. This x minus 2 means that x is equal to 2. That's our other x-intercept. Okay, so we have 3 total, 2 happening here, 1 happening here. Now, because this has a multiplicity of 2, this has an even multiplicity, which means I'm going to bounce / we're going to have a turning point at x equals -3. Because x equals 2 only happens once, and the number 1 is odd, this has an odd multiplicity, which means this is going to go straight through. Okay, so once again, multiplicity is the exponent that each factor is raised to. This is really x minus 2 to the first. That's why this is odd. This is x plus 3 squared, which is why this one's even. Okay, my degree is still 3. The multiplicity doesn't affect my degree. The last thing I want to do is find the y-intercept. It's easy to find the y-intercept here because remember, if I plug in x equals to 0, it's just going to be that last number. Okay, so let me label everything I have. Here's -3, here's 2, and I'm just going to say 18. So my end behavior, because this is a positive, there's a positive number in front of x cubed, and it's odd because my degree is 3, my end behavior is going to look like that. So I'm going to start there. Then, at -3, this is an even multiplicity. So I'm going to bounce here, and I'm going to go straight through through this x-axis, okay? So here's my bounce, here's my turning point at x equals -3. But because my 2 was odd, I just went straight through the x-axis. Okay, so let's try this one. And it might help if you pause the video and you try this one on your own. So x equals -1 with a multiplicity of 2, which means this is even, and I'm going to bounce, / turning point. X equals -2 is odd, which means this is going to go through the x-axis. These, remember, just have an exponent of 1. That's why this is odd. I'm looking at these exponents. X equals 4 is also odd because it goes through. Okay? Now, this polynomial has 1, 2, 3, 4 x's. So my degree is 4, and it's negative because of that negative on the outside. So I like to write everything out because then I am able to graph. The last thing we have to do is find the y-intercept. Remember, you have to plug in x equals 0. So let's do that. There's a negative on the outside. 0 plus 1 is 1 squared. 0 plus 2 is 2. And 0 minus 4 is -4. All of this ends up equaling +8 when I multiply them all together. So I'm going to plot everything I have. Here is my +8 on the y-axis. -1, -2, and +4. Okay? Because my degree is 4 and it's negative, these are going to, my arrows are going to face down. So that's kind of always how I start. Okay. I'm hitting the x-intercept -2 first. -2 is odd, so it's going to go through this x-axis. It's just going to go straight through. At -1, I'm going to have to bounce. We have this turning point at -1 because the multiplicity is 2. So when I come down, I'm going to have to bounce back up right here. I'm not going to go through the x-axis. I'm just going to bounce and come back up. Okay? I'm going to hit the y-axis, and then at 4, I just go straight through. So I'm just going to connect that. So see, at 4 and at -2, I went straight through because those had a multiplicity that were odd. Here, I bounced because that multiplicity was even. Okay? So make sure that you really understand that part. This second part goes into something a little bit different. So normally when I ask you to find all of the zeros of a coefficient, we are used to using synthetic division, but I normally give you a 0. You sometimes, if you're not given a 0, you're going to use the rational roots test. Okay, so the rational zeros test gives us a list of all the possible x-intercepts. That doesn't mean that they're all the x-intercepts, but my x-intercepts are in that list, okay? So here's a polynomial, and I'm just going to make this polynomial up. We normally are going to work with an x-cubed polynomial. So a, b, c, and d are just coefficients. When we are finding possible numbers for my zeros, we are going to use all the factors of the last term, always. And all the factors of the last term are d, and all the factors of a. So you take all the factors of the last term and divide it by all the factors of the first term, okay? Now, factors are numbers that when you multiply together give you that number. So for example here, I'm going to say x cubed plus x squared, plus 4x plus 2, okay? So I'm going to list all the factors of 2. Do you guys agree that 1 times 2 are the only things that multiply to give me 2, right? I'm going to make these plus or minus because 1 times 2 could give me 2, and -1 times -2. You always include a plus or minus in front of all of these factors because any variation of that can make 2. And here, there's only 1. 1 times 1 is the only thing that gives me 1. Okay, and I'm looking at these coefficients. So what multiplies to give me 2? Only 1 and 2. What multiplies to give me 1? Only 1. So when I list these, let's go to this example on the back. List all the possible rational zeros of the function. So I'm going to list all the factors of 6. 1, remember 2 times 3 would give me 6, and 1 times 6 would give me 6. Again, you always have to include this plus or minus in front, okay? What are the factors of 1? Because remember this coefficient is 1? Just 1. So when I divide these by each other, anything divided by 1 is just going to be the number itself. Like 6 divided by 1 is just 6. 3 divided by 1 is just 3. So my list is just this, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So if I took all of these numbers and I divided them by 1, I would just get these exact same numbers back, okay? So how many possible zeros are there? Well, there are 2 here because of the plus or minus, 2 here, 2 here, and 2 here. So there are 8 possible zeros. I know that even though this looks like there are only 1, 2, 3, 4 zeros, because each of them have the plus or minus, it counts as 2 for each, positive 1 and negative 1, positive 2 and negative 2, okay? How many real zeros can the function actually have? Remember, that is the same as the degree. So the degree of this polynomial is 3. So this function can only have 3 real zeros. So all of these numbers can't be our zeros, right? These are just possibilities. That's really what I want you to understand. That we're only going to pick, only 3 of them out of this list are actually going to be our zeros, okay? So here's the last part. We're almost done. Find all of the zeros of the function. So what you're going to have to do are test the possible zeros. What I want you to do is always start by testing 1. Then test negative 1. Then 2, and so on and so forth. Keep moving this way. But it'll be one of these, you guys. 1, negative 1, 2, something along. It'll be a small number. So always start with those numbers, okay? So what I'm going to do is now we're going to use synthetic division, just like we normally do, but we're testing. So I'm going to start with 1. And in my house, remember, we're going to go all the coefficients of this polynomial. So 1, negative 6, 11, and negative 6. So I'm going to write that here. So we're doing everything we normally do. We're just testing whether 1 works. So let's pull down this 1. 1 times 1 is 1. Negative 5 times 1 is negative 5. 6 times 1 is 6. And I got a remainder of 0. So I know 1 was a 0. We started with a good number. It's right. So always, if your remainder isn't 0, then erase it and try a different number. Okay, so we're okay. 1 is a 0. Now we just have to find 2 more, because remember, there are 3 total zeros, because that's the degree of this polynomial. So now this is like what we've been doing for a while. This is my number term. This is my x term. This is my x squared. So x squared minus 5x plus 6. Remember, you either factor or use the quadratic. Always try to factor first. So I'm trying to think of numbers that multiply to give me 6 and add to give me negative 5. So negative 2 and negative 3 work. Okay? So all of the zeros of the function are x equals 2, x equals 3, and don't forget, I need one last x-intercept, x equals 1. That's the first one we tested, okay? So just summarizing, rational roots test, you list all the possibilities, you start testing, always start with 1. If 1 doesn't work, that's okay, go to negative 1, okay? And then once you test with synthetic, once you find something that works, you're going to end up factoring or using the quadratic to find the other 2, okay? So make sure that you understand all of that. Feel free to pause, go back, rewind, whatever you need to do. I will see you guys tomorrow.